الله الرحمن الرحيم. This is the third part of the topic of line integral. The last time we found the line integral for the scalar function along the given curve C. And we say that if we have a scalar function f of x, y, and we need to evaluate along the curve C, given by C f x, y, ds is equal to integration from A to B, and the curve C to be parameterized by function f of t, g of t. ds is the square root of the derivative square plus g derivative square, g prime square, dt. This was the formula for integrating scalar function along a given curve C. In this part, we are going to speak about the vector field. We need to integrate a vector field along a curve C. So this will be the second type. Say definition. F is a continuous vector field. So we're asking about vector field, not scalar function. And C is a smooth oriented curve. The line integral of the vector field F along the curve C is given by of C F dot dr, where R is the vector function of the curve C. So in this time we are using the dot product. It is F dot dr, or it can be written as integration from A to B of the function of R of t multiplied by or dot product with the derivative. So if we have a vector function, then we are using the dot product to evaluate a line integral. So we have to just see the difference between these two integrations, scalar function and vector field function. For the scalar, just we substitute the given function for the parameter equation in that one, and for the vector field, we are using the dot product or f of the vector function of the curve that product with the derivative. For example, evaluate the integration f dot dr where f is given by or f of xy is equal to cosine x plus sine xj, and C is given by R of t equal minus y over 2 I plus tj, where t between 1 and 2. Let's evaluate this integration. This integral f dot dr. F dot dr is equal to, it is f of r of t. So from the parametric equation, or from the vector function of the x, I have c x is equal to minus y over 2. Given there, y equal to t. And the derivative for the vector function r of t is equal to, differentiate the first one with respect to t, it will be 0 plus 1j, or it can be written as 0 and 1. So the integration of f dot dr on the curve C is equal to integration from 1 to 2 f of rt. The formula says that f of rt means just replace the component of x and t with this one. X is equal to minus pi over 2. So this will be cosine of minus pi over 2 I plus sine minus pi over 2 j, dot product with j only dt. This is the derivative, r prime. And what we did, we replaced x by this component in the vector function r of t, and we multiply by that product with the derivative of r of t. That will be 0, 1 or only j. This is equal to integration 1 to 2. It is 0. Even if it is not 0, by the dot product will be removed. Sine minus pi over 2 is equal to minus 1j dot dt. Which is equal to the integration of 1 to 2 of minus 1. That will be minus c from 1 to 2. Will be minus, replace it by this 2 minus 1, I will get minus 1. So the value of this integration is equal to minus 1. So I have another one. Number 2. Evaluate C of F at CR, where C or given that the vector function or the vector field of xy is equal to y to power 3 I minus x square y j, and r t is given by e to power minus 2 t I plus e to power t j, where t between 0 and ln of 2. So for this one, I know that y equal to, or say x first, x equal to e to power minus 2t, y equal to e to power t. This one. And the derivative of the vector function r of t is given by minus 2 e to power minus 2t I plus e to power t j. That is easier to write it in that form. That will be minus 2 e to power minus 2 and e to power t. This is the derivative. So the integration, which is equal to from 0 to ln of 2 f r of t dot of the vector function r of t dt. F of r of t means replace x by its value and y also by its value. That will be equal to, bracket notation. The first component is y to power 3, and y is equal to e to power 2. So the first component is e to power t all to power 3. My function again is y to power 3. I replace y by e to power t, I will have e to power t all to power 3. The second component is minus x square y. X square is e to power minus 2t square multiplied by y, which is e to power t. This is only the first part. Now, dot product with the derivative function is minus 2 e to power minus 2t and e to power t dt. Now apply the dot product. I will have 0 to n of t. E to power 3t times minus 2, I will have minus 2 e to power t. This one with this one. E to power 3t times minus 2 e to power minus 2t. So we add the powers because they have the same basis. 3t minus 2t is equal to 1t. Now the second component with the second component. So it will be minus e to power minus 2t. This is e to power minus 4t times e to power t multiplied by this one, which is e to power t. I will have e to power minus 2t. Now integrate. We will have minus 2 e to power t plus 1 over 2 e to power minus 2t. Integration by substitution, I will have 1 half e to power minus 2t between 0 to ln of 2 or ln of 2. This will give me minus 2 e to power ln of 2 plus 1 half e to power minus 2 ln of 2 minus, now replace by 0, minus 2 e to power 0 plus 1 half e to power again 0. Or not 0. Yeah, 2 0 0. Minus 2 by the exponential and logarithmic properties, this term will cancel e. I will have multiplied by 2 plus 1 half, this is power, multiplied by 2 to power minus 2 minus 2 plus 1 half. That will be minus 4 plus 1 over 8 minus 3 over 2. You can take 8 as a common factor. It will be minus 8 plus 1 plus 12 over 8. And this will give me 13 minus 8 is equal to 5 over 8. So the answer is equal to 5 over 8. So this is the idea of finding the integration of a vector field along a given curve. It is f dot dr, which is equal to f of rt multiplied by the derivative of the current equation of the curve r of t.